Good evening, children. Today I welcome all of you to my Amila Academy channel. So today I am going to teach you a science lesson. This science lesson is very useful for the students in grade 6. Okay, children, today the topic is magnets, right? So I have written the very important points on this whiteboard, and I have some different types of magnets, so I am going to talk about those things. So children, magnets mean some special materials or substances to which iron, uh, nickel, steel, cobalt or mixture of them we call alloys will get attracted. So this magnet have a very special ability. To those magnets, some iron and these like special kind of things will get attracted. So here they are that there are in this world there are some special natural substances which is called magnetite here, which is called magnetite, natural magnets, magnetite, lodestone. So this lodestone also some kind of magnetite. So magnetite and lodestones are we call natural magnets. So on this earth we can naturally find these special rocks, pieces of rocks. So to those rocks or pieces of rocks that iron and nickel, steel, cobalt, those materials or alloys of them will get attracted. So natural magnets are magnetite or lodestone. But man has made some magnets which are called artificial magnets using the material iron, nickel, steel and cobalt. So what are the materials that used to make magnets? Iron, nickel, steel, cobalt. Right, children? So if we consider the shape of the magnet, we can give various names for those magnets, right? So here I have U magnet. So in this magnet you can see the U shape, right? So I have now you can see ring magnets. So this is ring magnet. Then this is like a bar. So this is we call bar magnet. So bar magnet, ring magnet and U magnet. Other than that, I have drawn here horseshoe magnet. It is like this way, horseshoe magnet. Here, ball-ended magnet, tabular magnet, like that button, shirt button. So tabular magnet. So what are the types of magnets? You should remember horseshoe magnet, ball-ended magnet, tabular magnet, U magnet, bar magnet, ring magnet. Okay, children. So if we consider a magnet, it has two poles. It has two poles. Here, if we consider the bar magnet, north pole, south pole, north pole, south pole. So here you can see N, you can see N. So red color, N, red color. So north pole, south pole, blue color. And if I use this U magnet, here you can see red color, north pole, blue color, south pole. If I use this ring magnet, here one side is blue, that means south pole, one side is red, so which is we call north pole. Okay, children. So substances which can attract some special iron-like things which are called magnets. These magnets we can divide into two groups. Natural magnets. What are the example? Magnetite, lodestone. Then man-made magnets which are called artificial magnets. So the man made these artificial magnets using iron, nickel, steel, cobalt. Iron, nickel, steel, cobalt. So the magnet has two poles, north pole and south pole, right? So here here I haven't iron powder, but some materials I have. So this is an iron nail. Here iron nail will get attracted to this magnet. So here iron nail will get attracted to this magnet. You can see here in a little power. Here magnet will get attracted. And if I take this Sri Lankan 5 rupee coin, so this is made from the stainless steel, so it will get attracted. And the 10 rupee coin, it will get attracted. And the 2 rupee coin, it will get attracted. But if I use this 5 rupee coin, it is not get attracted. So it is not made from iron, nickel, steel, cobalt or a mixture of them. It is not an alloy of these material. So it is not get attracted. Right? So here I have plastic clip. So this clip not attracted. This one not attracted. So we can divide the materials which are attracted to the magnet, which are not attracted to the magnet. So what are the materials which are attracted to the magnet? Iron, pins, stainless steel coins, and anything which is made from iron, nickel, steel, cobalt and mixture of them or alloys. So what are the materials which are not get attracted to the magnets? Wood, plastic, glass, and here gold, silver, copper, brass, those materials also don't get attracted to the magnets, right? Then you realize that of a magnet there are two poles, right? So if I keep a bar magnet, right, and I put the iron powder, so I can observe most of the iron powders will get attracted to ends of the magnet. So the power of the magnetism is very high at the two edges or the poles, not in the center. That in this north pole edge and south pole edge, the magnetism is very high. So here you will see, so these are lines. Here these are lines. These are poles. These lines are called magnetic lines. Here magnetic lines. It is like this way going. These lines are called magnetic lines, and the area around it which the magnetism is spread is called the magnetic field. So if I take a bar magnet and if I keep it and if I spill iron powder, we can observe like these patterns will created. These patterns will created. So the area around a magnet, the magnetic power is spread is called the magnetic field. So this power area we call the magnetic field, right? So you know we use compass to find the north direction. In the compass also there is a magnet. Other than that, pencil boxes, fridge door, motors, fans, in toys, loudspeakers, we can see the magnets, right? So here you can see south, north pole, north, south pole. These are called unlike poles. Here south, south pole, north, north pole, which are called like poles. Remember children, unlike poles of the magnet get attracted towards each other, but like poles of magnets repel away from each other, right? So you can see here. So here I have a bar magnet, right? I have a U magnet. So here now north north. I use the north pole of the U magnet and move it towards the north pole of the bar magnet. Here I take it very close. Then it will move. Here it will move. I can move it. Here it will move. It is going away from the magnet. Here it is going away from the magnet. If I use another bar magnet, here it will get away. It will repel from this north pole. So like poles will repel. If I use this south pole, here it will go away. But here I have north pole of this bar magnet. Here I have south pole. Then we'll see what will happen. It will get attracted. It will get attracted. Here I use here U magnet. I use a bar magnet. Here north pole is there. Here blue color south pole is there. Get attracted. But if I use the north pole, like poles, here it will get away. It will repel. Then we can come to a conclusion, right? So the unlike poles of magnets will get attracted. Then south pole of another north pole of a magnet will get attracted. North pole of a magnet will get attracted towards to the south pole of another magnet. But same poles, like poles will repel each other, get repelled. Okay children? Now you can do these things at home. Here I use this ring magnet, right? So here you can move this one using here. That is also attraction. You can move this. You can see here moving. Like these activities you can do being at home in this COVID-19 season, right? Now, children, here I have drawn some figures here. So you have a magnet like this bar magnet you have, but in that magnet the poles are not mentioned. How to that find the north and south pole of this bar magnet? So this is not the school lab, so I can't do the experiments we are doing like in school, but get an idea. So you have a magnet, you don't know the poles of the magnet. So use a string and hang the bar magnet using the string and keep it for some times. So you will observe it will still towards the north and south direction. If you hang this unknown magnet using a string string, and if you keep it still, after moving it will remain still, then you can observe this unknown uh, magnet will remain still in the north-south direction. How do you find it? If it is still, you can keep a compass and see this is that remain still into which direction, right? Then you are given two types of bar magnets. You are given some pins. How do you find the most powerful magnet? For that, here you have iron nails. You see, you have like that iron nails. Then use the first magnet and keep it like this, right? Then some of the iron nails will get attracted to the end of this magnet. Count the nails and write the number, and use the next bar magnet and keep it very close to the iron nails, and like that it will get attracted, and count the nails which got attracted to the end of the second magnet. Then this magnet, how many nails how many nails got attracted to this magnet? If we consider this magnet got attracted 10 nails, iron nails, this got attracted 5 iron nails. So this is the most powerful or more powerful magnet if we consider or if we compare it with this second magnet. So these activities, if you have these things and if you can buy these things from the shop, you try to do these activities being at home. So I will give assignments to do those things, and send me the photos or the videos through WhatsApp. Okay children, so with the support of these things, and I did this lesson, I think you realize it. Let's go to this summary of the lesson, right? So the substances which attract iron, nickel, steel, cobalt, or mixture of them or alloys are called magnets. So naturally we can find some materials on the earth which have the ability of attracting iron. So these are called natural magnets. What are the example? Magnetite and lodestone. But the man has made man-made magnets or artificial magnets using iron, nickel, steel, cobalt, right? Which are called man-made magnets or artificial magnet. So there are various types of magnets: horseshoe magnet, ball-ended magnet, tabular magnet, U magnet, and ring magnet, right? So in any magnet there are two poles, north pole and south pole. North pole is red, south pole is blue, right? So these magnets we can see in pencil boxes, in fridge doors, motors, fan, in some toys, in loudspeakers, in the compass. We use the compass to find the north direction, right? So here, unlike poles will get attracted, but like poles will not get attracted. They will repel. They will get repelled. Okay children? And the most powerful places of a magnet is the end places. That means pole places. So around the magnet, the magnetism is very high. That area we call magnetic field, right? And you can do some practical experiments. First one is, you are given unknown magnet, how to find the north and south pole of the given magnet with the help of compass, right? And here you are given two types of magnet and some iron nails, how to find the more powerful magnet. So do that experiment being at home. So you know some materials will get attracted to the magnet. So magnetic material, right? Some materials will not get attracted to the magnets, which are called non-magnetic materials. Okay children, I think you realize that subject matter which is very related to the grade 6, and this lesson is very helpful for the grade 5 who are going to write their primary certificate, right, examination, and you learn about magnets. I think here with the support of the pictures and materials and the support of the note I have written on this whiteboard, you will try to do something being at home. So send me the photos or the videos you are doing using the magnet at home. Please children, read the lesson of the textbook of grade 6 Sri Lankan local syllabus, right? I think you realize this lesson and I think you become very happy. So I will send the assignments through WhatsApp, and remember to subscribe my channel and remember to click the bell icon so you will get my videos as soon as possible if I release those things into the internet. So children, goodbye.